in this module, we shall talk about limit of exponential function. What are the exponential functions? We talk about the exponential function whose base is a constant and power or index is a function of x. Now, whenever we have such functions of this form, having a number raised to a function of x, or like this 4x square, or 3 raised to sine x, 3 raised to log x, all such functions we call it as exponential function. To find the limit of this, we have this type of function. We have one category, one formula, limit x tending to 0, a to the power x minus 1 upon x is log a. This is a formula that we will be using. Now, if you apply the L'Hopital's rule, we can see that when you differentiate the numerator, if I differentiate the numerator, d by dx of a raised to x minus 1 upon d by dx of x, we can see when I replace x by 0, 1 minus 1, you will get numerator 0. When you replace denominator, you get 0. So it is 0 by 0. So L'Hopital's rules can be applied. So I differentiated numerator, differentiate the denominator, you will get a raised to x log a upon 1. When you apply the limit, this will become 0 and hence your answer will become log a. So L'Hopital's rules directly, if you apply, you will get the answer in this manner. Now, if you want to apply this formula directly without applying the derivative method, the L'Hopital's rule, we can directly calculate the limit in this manner. Limit x tending to 0, let's say 4 raised to x minus 1 upon x. If I want to apply this formula, what are the criteria that should be satisfied? First criteria, the index should tend to 0. What do you mean by index? The power of a, power of the constant should tend to 0 when you apply the limit. Second term in the numerator, should be minus 1. So second term in the numerator should be minus 1. Third condition, index should be equal to the denominator. If these three conditions are satisfied, then your answer is log of whatever the base of the exponential term, log of the base. So you can notice that when I'm applying the limit, x is tending to 0. So then second term is minus 1. The denominator and the index are equal, hence my answer is log 4. My next question is whether can you apply for this particular function, limit x tending to pi by 2, 5 raised to cos x minus 1 upon cos x. Is it satisfying all the conditions? When I apply the limit, it becomes cos pi by 2. Cos pi by 2 is 0. So we can apply the formula. Is it having this condition satisfied, this condition satisfied, this also satisfied? Hence, my answer is log 5. This is how we can calculate this directly by just seeing whether this satisfies all the three conditions of what is written here. Now, let's have a look at another problem where we are going to see that limit x tending to 0, 4 raised to 3x minus 1 upon x. First condition satisfied, that tends to 0. Second condition satisfied, minus 1 is present. But what you notice is, index and the denominator are not equal. So what I can do is, I can divide by 3 and multiply by 3. Now, this will become log 4 and become 3, and answer is 3 log 4. So, if there is a coefficient here, what you notice that coefficient becomes a prefix of your answer. Limit x tending to 0, 5 raised to 2x minus 1 upon x. Directly, coefficient is 2 log 5. You can directly write the answer. Now let's have a look at another kind of problem where it is not, second condition is not satisfied. Let's say limit x tending to 0, 3 raised to x minus 2 raised to x upon x. Which condition is not satisfied? This is satisfied, power is tending to 0. Second term is not minus 1. We do not have the minus 1 in this answer, this question. So what we will do? We will subtract a minus 1 and add a minus 1. Now, if I separate the denominator, I need to apply the formula 2 times. 1 in this and 1 in this. So this became log 3 and this became log 2, and hence my answer is log 3 by 2. So this is my second type of problem where minus 1 is missing in the answer. Note that there are two kinds of problem in this. One having denominator x, later on I will have denominator x square. Let's look at this problem of the same kind where denominator is x. So I am going to discuss all the problems with the denominator x. Limit x tending to 0, 3 raised to 4x, 5 raised to 2x minus plus 4 raised to x minus 3 upon x. Whenever denominator x we are in short of minus 1, whenever we are in short of minus 1, it can be adjusted within. For example, this can be written as 3 raised to 4x minus 1, 5 raised to 2x minus 1, 4 raised to x minus 1. How many minus 1? 1, 2, 3 and equal to minus 3. Because you know that when I replace x by 0, I should end up in 0 by 0. If it is not ending up 0 by 0, then we know directly the answer. If numerator alone is 0, answer is 0. If denominator alone is 0, answer is not defined. And if both are 0, then only we require the formula. So naturally this will, if there are three terms positive, naturally this will become minus 3. Otherwise it will not end up in 0 by 0. Now distribute x to each one of them. Now there is a coefficient here. So answer is 4 log 3. There is a coefficient here, 2 log 5. There is no coefficient here, so log 4. If you want to write as single log, 3 raised to 4 into 5 square into 4, you can write it this way and write your final answer. So you need to solve just mentally this minus 3 adjustment. You don't have to write all the steps. You can directly write the answer by looking at it. That is the aim of this exercise. Now let's have a look at this problem. Limit x tending to 0, 5 raised to x minus 2 raised to x minus 3 raised to x plus 1 upon x. Now check when I put x as 0 here, 1, minus 1, minus 1, 1. So numerator is giving you 0 by 0. So if it is 0 by 0, the method of adjustment, method of getting this minus 1 is just by adding and subtracting. So I am going to subtract a minus 1. I've added a minus 1. Minus of minus is plus 1. Subtracted 1, added 1. And here I took a minus common. So everything is adjusted. I've subtracted 1, added 1, and this minus and this combined, I took a minus common. Now this became log 5 minus log 2 minus log 3. Hence my answer is log 5 divided by 2 into 3. So log 5 by 6. You can answer in this manner. 1. You have seen a raised to x, b raised to 2x, 2 raised to x plus 1 here. So here what we'll do is, we will write first of all, when I take x as tending to 0, this is a raised to 0, 1, b raised to 0, 1. Here the power is not tending to 0, the index is not tending to 0. So I will first make the index tends to 0 by writing it as 2 raised to x into 2 raised to 1. 2 raised to x into 2 raised to 1. A raised to m plus n. A is a raised to m into a raised to n. That's what I applied. And that is became 2, and hence I can write this way. Now to get the second condition satisfied, I need a minus 1. So a raised to x minus 1. B raised to 2x minus 1. B raised to 2x minus 1. So how many minus 1? 2 minus 1. Minus 2 raised to x into 2. Whatever the extra numbers I put, I add that. Minus 1 will give you minus 2, compensated with a plus 2, divided by x. Now I can write this as limit x tending to 0, a raised to x minus 1 upon this x, b raised to 2x minus 1 upon x. Now I have 2 common, minus 2, 2 raised to x minus 1 upon x. Now I can write this answer as log a plus log x is having a coefficient 2 log b minus 2 log 2. So final answer I can write as log a, this power b square divided by, because of minus division, and 2 square. So log AB square divided by 4. This would be my answer. This way we can calculate this function. Now let's have a look at one more function which will be little more easier to calculate. Imagine I have limit x tending to 0, 3 raised to 2x minus 4 raised to 3x divided by sine x, sine 2x. In this case, when you see sine function, we need to remember the formula, limit theta tending to 0, sine theta upon theta is 1. We need to apply this formula. So, I need a theta, which means I need a 2x in the denominator. So, I am first going to bring an x. So, 3 raised to 2x minus 4 raised to 3x divided by x whole divided by sine 2x divided by x. So this I have done. Next I have divided numerator and denominator by x. Now what I am going to do is, I will bring a minus 1, which I do not have here is a minus 1. 3 raised to 2x minus 1, minus 4 raised to 3x minus 1. This 1x over here, 1x over here, divided by sine 2x upon 2x into 2. To make the angle and the denominator same, I divide and multiply by 2. Now I can directly write my answer. Log 3 raised to 2x, there is a coefficient here. So 2 log 3, there is a coefficient here, 3 log 4 divided by 1 into 2. So my final answer is log 3 square divided by 4 cube whole divided by 2. This will be my final answer. 3 square, how you got? This 2 and this 4 cube. You can write as 9 upon 64, half 9 upon 64, or you may take 2 common, or simplification further, this can be done. Now all the problems what I did had denominator only x. When the denominator become x square, it is necessary that I have formula multiplying each other. I need to have formula like this, a raised to x minus 1, b raised to x minus 1. Then only x into x square can be adjusted. So my method for this problem will be factorize this into 2 factors. So 6 raised to x minus 3 raised to x. The common is 6 is 2 into 3. I can write this way. Now between this 3 raised to x is common. Between this a minus is common, like how you solve a quadratic equation. So 3 raised to x minus 1 into 2 raised to x minus 1 becomes your factors. So the numerator can be written as 3 raised to x minus 1 into 2 raised to x minus 1, and the x square can be distributed in this manner. Hence my answer is log 3 into log 2. Remember, log into log, we do not have any formula. You cannot write it as log 5 or log 6 or anything. We have to leave your answer in this manner only. So when denominator is x square, we need to adjust the 2 numerator into 2 a raised to x minus 1, b raised to x minus 1. So you need to factorize. So whenever denominator is x square, the numerator has to be factorized. This is a point to remember. And you will check whether it can be factorized. 6 is 2 into 3. So 3 raised to x minus 1 into 2 raised to x minus 1. You may not do this whole directly, you will be able to derive the factors. For example, another one, I'll just quickly do it. Similar problem. Limit x tending to 0, 10 raised to x minus 2 raised to x minus 5 raised to x plus 1 upon x sine x. Then what should I do? 10 is 2 into 5, so I can factorize it. So the factors will be 2 and 5 are factors, means 2 raised to x minus 1, 5 raised to x minus 1. You don't have to factorize all the time. Every time it will match. 10 is 2 into 5, then 2 raised to x minus 1, 5 raised to x minus 1. Divided by x sine x. Now, x sine x, it can be made into formula only if you have x square in the denominator, because if I divide only by x, what will happen? Only by x, this will get cancelled. So I cannot apply sin theta upon theta. So I need to divide numerator and denominator by x square. 1x will go away. Now this x square will be distributed in this manner. We distributed in this manner. So I can put the limit in this way. So this is log 2 into log 5 divided by 1. So your answer is log 2 into log 5. So this is how we can do. So remember, when x sin x is present, it's like x square. Because if you want to bring sin theta upon theta, you need to divide numerator and denominator by x square. Hence, this problem should be treated as an x square problem, because x sin x to convert into sin theta upon theta, you need to divide numerator and denominator by x square. Now, I can also give you this problem in another way. Limit x tending to 0, 25 raised to x minus 2 into 5 raised to x plus 1 upon x square. Again, denominator is an x square. Here, you will notice that 25 raised to x is 5 square raised to x. This is 5 raised to x the whole square. Because a raised to m the whole raised to n and a raised to n the whole raised to m both are equal. So I can interchange this 2 and x. So if I do so, this will turn to 5 raised to x the whole square minus 2 into 5 raised to x. Instead of 1, if I write 1 square, you will notice that it is a square minus 2ab plus b square. And you know that a square minus 2ab plus b square is a minus b the whole square. So I can write this as limit x tending to 0, 5 raised to x minus 1 the whole square divided by x square. So this is nothing but limit x tending to 0, 5 raised to x minus 1 upon x the whole square. Both the squares are combined together. Finally, this became log 5 the whole square. Remember, most dangerous thing that happens in this problem is you will write it as 2 log 5 and this is wrong. Log 5 the whole square means log 5 into log 5. There is no formula for log 5 the whole square, which can be written in this manner. Log 5 square can be written in this manner, 2 log 5. Log 5 the whole square cannot be written in this manner, hence it is wrong. So you need to leave your answer log 5 the whole square. Remember, log into log, there is no formula. So log 5 the whole square will be log 5 the whole square only. You cannot simplify further. This problem can be done in 2 ways. You can use the formula. You can also use L'Hopital's rule. I'll first do by the formula. If I want to apply the formula, I need to have tending to 0. So I will put x as 1 plus h. X tending to 1 means x is either little more than 1 or little less than 1. If h is a positive number, little more than 1. If h is a negative number, less than 1. But as x is tending to 1, h will tend to 0. So I can write this as limit h tending to 0, ab raised to, x is replaced by 1 plus h, ba raised to 1 plus h, divided by x minus 1 will become 1 plus h minus 1. Which I can write as limit h tending to 0, index is 1 plus h, so ab into b raised to h, this minus ba into a raised to h divided by h. This is equal to limit h tending to 0, ab is common, so b raised to h minus a raised to h upon h. Now we need a minus 1. And you know that if the degree is 1, you have to do minus 1 plus 1 method. So AB goes outside the limit. So I can write B raised to h minus 1, A raised to h minus 1 upon h. So which I can distribute it as AB into limit h tending to 0, B raised to h minus 1 upon h minus limit h tending to 0, A raised to h minus 1 upon h, and write this answer as AB into log B minus log A. That is AB into log B by A. So you can apply this formula directly. You may not write these steps. Directly from here log B, log A, and finally log B by A. You can apply this. This problem also can be done by derivative method, which is much simpler. I just showed you how when x is not tending to 0, how to apply the problem. I've just showed you, but if I'm doing this in the exam, I will always prefer the derivative method, L'Hopital's rule, and that would give me limit x tending to 1. You can see that this became 1 AB, this became 1 AB, AB minus AB 0, it is 0 by 0, so derivative method can be applied. When I differentiate, A is a constant, derivative of b raised to x, b raised to x log b, and b remains as it is. Differentiate a raised to x into log a, divided by derivative of x minus 1, that is 1, derivative of x is 1. Now replace x by 1, so ab log b minus ba log a. What is common? ab is common, so log b minus log a, and we come to log b by a. So this is also a very short method. You can apply whenever denominator is of degree 1, the derivative method will apply much better than any other method. So you should always look at that. Learn how to quickly answer the question. E raised to 2x minus 1 upon x cube. So I can write this as limit extending to 0. E raised to 2x minus 1 upon x, and 1 minus cos 2x upon x square. And you can directly write your answer. This is 2 log e, and log e is 1, and this is 2 square by 2. Remember this, limit extending to 0, 1 minus cos kx upon x square is k square by 2. Directly. So your answer became 2 into 4 by 2, answer is 4. So you need to calculate just looking at the answer, and this is a method you need to adopt. Now let's have a look at some other question where we are going to calculate it in one step. Limit extending to 0, 5 raised to x plus 5 raised to minus x minus 2 upon, let's say, x sin x. One method you can apply derivative method. Another method is, if you take this 5 raised to x as 1 by 5 raised to x minus 2 upon x sin x. When you take the LCM, it will turn up to be a perfect square. 5 raised to x whole square plus 1 minus 2 times 5 raised to x divided by 5 raised to x into x sin x. This is multiplied with this and got this, and the LCM comes to denominator. So it finally turns to be a square b square 2ab. So 5 raised to x minus 1 the whole square. If you have not understood, just expand and see this, you will get the same term. Divided by 5 raised to x into x sin x. Now, if you divide by x square, if you divide numerator and denominator by x square, here 1 x will come, here 1 x square will come. This x square it is not x, because it's inside the bracket. Now, this x and this x will go away, and everything is turned to a perfect formula. So it became log 5 the whole square divided by 5 raised to 0, which is 1, sin theta upon theta, which is 1, and the answer is log 5 the whole square. Directly you can write the answer. So the importance here is 5 raised to minus x and 5 raised to x comes here. You must write 1 upon 5 raised to x and take LCM. Then this turns to be a square plus b square minus 2ab, and which turns to be a minus b the whole square, where b happened to be 1. That's why a minus b the whole square has come. Once you get the whole square, you need x square to match the formula. So divide numerator and denominator by x square. Then we will, here you can see 49 raised to x, a perfect square, 4 raised to x, a perfect square. Such type of problem, identify the perfect squares here. So 49 can be written as 7 square. So 7 raised to x the whole square minus 2 into 4 raised to x is 2 raised to x the whole square. And you can see that if you multiply this both, you get 14 raised to x. So 7 raised to x into 2 raised to x upon x square. Now clearly this has turned to a square minus 2ab and b square. So I can write this as 7 raised to x minus 2 raised to x the whole square. This is a minus b the whole square. A is 7 raised to x, b is just 2 raised to x upon x square. So both of them have a square there. So next step I can write this as limit extending to 0, 7 raised to x minus 2 raised to x upon x the whole square. When both of them are square, convert it to a whole square. Now you know this problem. If square is not there, what do? You put minus 1 and plus 1. You will treat it as an x problem, not x square problem. So this you will write as limit extending to 0, 7 raised to x minus 1 minus 2 raised to x minus 1 upon x the whole square. So this can be written as log 7 minus log 2 the whole square. So final answer is log 7 by 2 the whole square. So this will be my final answer for this problem. Problem can be done either by derivative method. If you are doing derivative method, you need to differentiate 2 times. So the better than that, just one step you can complete the problem by just subtracting 1 and adding 1. Subtracted 1, added 1 upon x square upon x square. This is perfect formula, a raised to x minus 1 upon x. So this is log e, and this is half, because we have 2 formula here. Limit x tending to 0, a raised to x minus 1 upon x is log a. Second formula we applied is limit x tending to 0, 1 minus cos kx upon x is k square by 2. K square by 2. So we have got k here is 1, so 1 square by 2. So 1 plus 1 by 2 log e to the base c is 1. So your answer is 3 by 2. So this way we can do it just mentally. But if you try to do by derivative method, it is not easy to do. So all the problems you cannot apply the derivative method. If you have no other alternative, then you can apply. You take more time, but this can be mentally done if you are finding out the derivative. Given to you, m and n are 2 positive integers. The value of m and n is greater than 1. This limit gives you minus e by 2. Then what will be the value of m divided by n? This is a question. It's asked in JEE Advanced 2015. Okay, first thing, you will apply the limit directly and see what happens to the power. When I put x as 0 here, cos 0 is 1. So e minus e will give you 0, and this also gives you. We need to apply limit x tending to 0, a raised to x minus 1 upon x is log a. If you are applying this formula, the power should tend to 0. But if I put x as 0 here, power tends to 1. Secondly, in this place, I require 1. And how do I come to know I need to apply this formula? Because base and power, base is a constant and power is a function of x, which means I need to apply this formula. So first step, what I am going to do is, I am going to take an e common. Then, if you know that a raised to 5 plus a, if I am taking, or minus a, if I am taking an a common, a raised to 4 minus 1, what happens to the power 5? It reduced by 1. So what happens to e raised to cos x raised to n minus 1 divided by x raised to n. Just check. If I open the bracket, power will be added, this minus will go. If I open the bracket, this will come back to e. So both are equal. Now, after this, I have to look at this power and denominator should be same. Now you have noticed that the power is tending to 0. If I put x as 0 here, cos 0 is 1. 1 minus 1, 0. The power is tending to 0. So this is like your x here in this problem. So limit x tending to 0. Okay, let me take this e outside. I took the e outside. And I'm going to make this power come in denominator. E raised to cos of x raised to n minus 1 divided by cos of x raised to n minus 1 into cos of x raised to n minus 1 divided by x raised to n. Now, I have completed this into this format. Hence, this whole answer is log e. So, I can write e into log e, which is 1, into limit x tending to 0. I have formula with 1 minus cos theta. Remember this formula? 1 minus cos theta upon theta square, limit theta tending to 0. This formula, if I want to apply, I need 1 minus, so take a minus common. 1 minus cos of x raised to n upon x raised to n. Now, this should give me minus e by 2 as the answer, which means this and this will get cancelled. My answer should be minus half. If my answer to be minus half, this should be square of this. You can say theta and theta square. So that means this x raised to m should become x raised to n the whole square. I have my limit x tending to 0, 1 minus cos x raised to n here, then the denominator should be x raised to n the whole square. Which means this m should be equal to 2 times n. That means m by n should be equal to 2, then only my answer will be correct. I hope you understood. 1 minus cos theta upon theta square, that means x raised to n, x raised to m should be equal to x raised to n the whole square. Then only this will become half. Otherwise it will not become half. So x raised to m should be equal to x raised to 2n, which means m should be equal to 2n, which means m by n should be equal to 2, and that is your answer. We can also do this problem by derivative method. So let's see how it works in derivative method. When you differentiate the numerator, it becomes e raised to cos of x raised to n minus sine of x raised to n into derivative of x raised to n divided by derivative of x raised to m, and that limit should be minus e by 2. Now I can here directly apply the limit. This becomes 0. Okay, we'll do separate it first of all. E raised to cos of x by n and sine of x by n, the minus sign I'm putting outside. Then I'm dividing by an x raised to n, multiplying by an x raised to n. Then I have an n here and m here. So let me write that in the last. And I have n by m. This limit should be equal to e by 2. And this minus and this minus we can cancel off. Minus and minus will get cancelled off. This became e raised to cos 0. This became 1, sin theta upon theta is 1. This become x raised to 2n minus 1 upon x raised to m minus 1. N by m is equal to e by 2. Now there is, so now we can have a look at this. This limit, both sides will be equal only when this and this are equal. That is 2n minus 1 should be equal to m minus 1. So 2n should be equal to m. So m by n should be equal to 2. We have got the answer. So if I put m by n as 2, naturally everywhere it will satisfy. This will become 1 by 2. This will become 1. This will become e. And you can see that both the sides are equal. So m upon n should be 2. What I did is this power should be equal to this power so that they get cancelled. From that you get m by n is 2. So n by m will be 1 by 2. And you will see that both the sides